One of the nice things about the Castle Bank deposit is that even when you can't get out on field work because, it's winter in Wales, we still have boxes of stuff that we collected earlier still to go through. And sometimes one of those turns up something quite surprising. Hello again, everyone. I hope you've had a lovely Christmas. And if you're watching this 6 months later, then I hope you had a lovely Christmas anyway, even if you can't remember it. Anyway, Christmas is the time for silly jumpers to come out. And this one is a new acquisition, of course, from my lovely Auntie Jenny. Thank you very much indeed. I think you're probably here somewhere. Oh yeah, there you are. Hello. Okay, so today we've probably got a relatively short one for you. It's just something that we found recently and I want to tell you about, even though we can't yet give you definite answers to what we're looking at. Not definite ones. And probably if we do get definite ones and it is what we think, then that will be in the members area until we actually get it published. So this is another new find from the Castle Bank Biota. For anyone who's new here, this is a Middle Ordovician Burgess Shale-type fauna. So this is one of these sites which preserve soft-bodied fossils. And it's an extraordinary one in that it preserves extremely soft tissues in great resolution. But most of the fossils are tiny. So, well, I say tiny, they're actually quite big compared with some other things, but they're up to sort of 2 or 3 millimeters in general. So that's the sort of scale of fossils that you're looking at, and yet they do preserve remarkably fine detail. I have an introduction to the Castle Bank Biota here, and there's a series of other talks about particular fossils, and that will increase over time. If we're doing things which are sensitive, so the papers haven't been published yet, and we can't put them out online because of problems with press releases, at least not publicly availably, then we put them into the members area, which is for people who would like to support the channel at £3 or £4 a month, and then you can also get extra bonus videos about unpublished stuff. But what we've got is one specimen among probably 100 or 200 that we've put aside, unpacked from the last days of fieldwork last year. So towards the end of the summer, you just want to maximise the good weather while you can and go out collecting every day, and you get a pile of boxes building up in the study which you don't have time to unpack. So we've now done the unpacking and started to go through the backlog of some of these specimens. And usually these things are sponges or graptolites, things that you knew what they were at the time, and they're just going to go into the collections until we actually write up that species. And that's fine, just more material is lovely. But then there's occasionally other things, actually quite commonly other things that we're not quite sure what they are in the field. Sometimes we can see a sort of glimpse of them. We know roughly what it is, but we can't see the details. We don't know how interesting the specimen is until we get it to the big microscopes upstairs. And when that happens, you can find something that's quite unexpected. So this particular specimen, which I'll have to show you under the microscope because you really can't see anything, I don't think, on here, but just to give you the flavour of what you can't see, there's a circle sort of scratched on the rock there, and inside that circle is a faint grey area, which I'll put under the microscope and show you. Okay, here we can see that there is a tangle of little grey lines there. It's about 2 or 3 millimeters across. You can see the little pale grey scratches where I've been preparing it out, so some of that wasn't exposed before. We zoom in and you can see it is indeed a tangle of grey lines. And when you see something like that in the field, you might think it's a cluster of conodonts, for example. Conodonts, for those who don't know, being the teeth of early fish-like animals. And we've had a couple of little clusters. No soft tissues yet, but they definitely did live there. But these are clearly not they. These are organic. Let me just put the polarizer in. And zoom in further. And it's difficult to make much of this out at all. But you can see that each of these lines is surrounded by a fainter area around it. And you zoom in detail and you can see that that fainter area also has little transverse lines going across it. And if you zoom into this bit in particular, you can start to see there's sort of a ridge, almost like a seam going down the middle, and then a series of little oblique lines coming off it. And when you have the fully cross-polarized view, you can start to see this is actually a cluster of little tubes. So you've got the sort of very pale areas which are elongate structures with transverse lines with one little ridge or seam going down the middle. Now we have seen some of these before, normally just isolated ones, and it's very clear that they're actually little tubes. Extremely delicate little tubes. Things made of organic material, like paper effectively, really, really thin. I mean, these things are only 2 or 3 millimeters long and just a small fraction of a millimeter wide. But they all show this sort of sinuous line going down lengthways, not down the middle because it's at different positions along the width of it. And coming off from that, there are these very fine little filaments or ridges or annulations. So this was a tube that was made of organic material built up in very thin increments with a seam down one side. So how many things make tubes? What are the options for something like this? To start with, the first thought was something like a terebranch. So graptolites have slightly more obscure living relatives, things like terebranchs and cephalodiscids, and something like that could have been producing tubes which were very, very delicate. And these are much, much weaker in terms of the preservation. They're much fainter than the graptolites that we see, and also than rhabdoplurans that we get at Castle Bank. So it's clearly not one of those, but we were thinking, okay, little tubes, sort of vaguely annulated, it might be something like a graptolite. However, they're not the only things that make tubes. So without having the animal, you really can't tell much. And one of the other options is things like polychaete worms, annelids. Some of these make either agglutinated tubes or sort of parchment-like things. And these also can have a fairly decent fossil record, potentially. And the smaller they are, of course, the more delicate they get. But it's possible that we've got some sort of worm making a tube like this. Other options, there are even arthropods that make tubes, things like the larvae of caddisflies today. But then, not alone in this, but that's one group of little arthropods, in that case insects, but crustaceans also, that secrete a little papery tube to live inside. There are also various other groups of worms, like priapulids, at least Cambrian ones, that can secrete an organic burrow lining. So not a freestanding tube, but they line the burrow inside the sediment, and then that can be preserved. So there are actually quite a lot of different possibilities for what could make something like this. Which is fine. Sometimes you just have mysteries and you keep twiddling your thumbs and waiting for an example to turn up which actually shows the animal inside it. And we thought that this was just another example of one of these little clumps of tubes, and it'll give us a bit more information on the variability, but can't do much more with it. Then we started looking a little bit closer. One of the really remarkable things about Castle Bank is that the fossils are often more obvious, darker and blacker, when there is actual soft tissue there, rather than just slightly more recalcitrant bits. So we have here, if we take the polarizer out a bit, a series of fairly faint grey structures which are the tubes. But as we were looking around, we suddenly realised there was a bit here that was actually significantly blacker than the rest. Now, if we were to zoom in on this, you can start to see that this looks a little different to the rest of the tubes. In fact, there's regularly sort of serially repeating structures in this part, almost like it's kind of segmented, which is very interesting in itself. But then it sort of goes through the rock at a slightly odd angle, and then comes out here where we seem to have a sort of possibly an end. And this is where it gets really, really interesting. But it takes a little while to fiddle around with the focus and the contrast before we can actually see the details clearly. Now this whole structure is pretty small. It's about 1 millimetre long and a lot less than that wide. So you're looking at an absolutely minute little thing. But that does mean that it's exactly the right size to fit inside these tubes, which is interesting. The question is, what on earth are we looking at? And for this, we're at the limit of the magnification on these microscopes. We can see more clearly down the eyepieces because we have an extra doubling of the magnification through the eyepieces, but we can't illustrate that. But still, we can see details here which are very intriguing, and we can tease out quite a bit by using the brightness and contrast after we've taken the pictures. We've also stacked various images together so that the focal planes are all combined into one image, and what you end up with is something like this. And to start with, what you can say straight away is that it is vermiform, meaning worm-like, which is a highly non-technical scientific term, but basically means it's long and thin and doesn't have legs. So what it does have is lots of segments. And this rules out quite a lot of groups. So the paleoscolecids, which we covered recently, don't have anything like this type of segmentation, with these very elongated lateral bits coming out the side. It's also got differentiation, so the front has fewer larger segments and then some spiky bits coming out the front than the back does, which is much more regular. So all of this looks, at first glance, a bit like a polychaete annelid, which is one of the groups that I mentioned does actually make tubes. But to do any more than that, we need to look a lot closer. This is a stacked image of the front of this potential worm, and you note the scale bar along the top is 1 millimetre, so this is what, 0.1 millimetres wide? It's ridiculously small. And yet we're still seeing structures here. That's the limit of the camera, but we can still zoom in digitally and show you a few more details that I think are there. And when you do magnify this to the point where it starts getting pixelated, you can start to see that there is actually quite a lot of structure here. I've now taken the liberty of showing you what I'm seeing at first glance here. So you highlight these different features and you see it has a midline, that's the dashed line in the centre, and coming out from the end of that, at the very end, is this long sort of spike along the midline. Either side of that, the first thing we have are a couple of curved hook-like structures, quite soft ones, they're not very well preserved. Then you have the first pair of what would be parapodia, so the first segment of the animal, then the second, and so on. But on those parapodia, you can also see at the tips there is just the faintest hint of bunches of bristles. That's now ridiculously tiny, but you can see there are a series of little hair-like structures coming out the end of, well, particularly this parapodia, but also some of the others as well. Right then. That is interesting, but it's important to realise what stage this is at in the research process, because we have not come to a conclusion at all. What we've got now is a thing that looks like it might possibly be an annelid. The next stage, of course, is then to start testing this idea. So we've got features which we can just about make out that are consistent with what you might expect to see in annelids from just general knowledge. You then start going to the literature, going into the references, finding if there are particular groups of annelids and particular groups of polychaetes that might match up quite closely with the features that we're seeing here. When you do that, we find that actually, yes, there do seem to be. There are quite a range of polychaetes available, and this is just the first book that I have handy, which is the Handbook of the Marine Fauna of Northwest Europe. It's a nice light, slim volume, pocket-sized, but it also has quite a large coverage of various groups of polychaetes. And you sort of browse through pages and pages of this until you come to things that start looking vaguely similar. After pages and pages of things where you can barely see the segmentation, or which have a cluster of tentacles at the end of the body, you suddenly come to this page which has a few small families together, and these ones include the Poecilichetidae, the Chaetopteridae, and the Magalonidae. And these include worms which have very obviously pronounced segmentation. They've got extensions to the side of the body which are very, very clear. And at the anterior they have similar structures. You've got the first pair of Parapodia seem to be almost sort of hooked round. There's an axial spike on the midline of various sizes. And there are also little clusters of tiny bristles in about the same sort of size and shape and arrangement as we're seeing in this fossil, potentially. You then have to start actually reading the thing rather than just looking at the pretty pictures, because I think we've just about grown out of that stage. But anyway, when you do that, you find that for the Magalonidae, which is on the same page and it's closely related but not the same as the one we were looking at that was really similar, it says, burrowers in sands and muds. Most have no permanent tube, although thin parchment-like tubes have been reported in some species. Well, thin parchment-like tubes, eh? Okay, this is obviously not the same animal as something that we've got alive today. It's in the Middle Ordovician. We have a reasonable record of annelids going back even into the Cambrian, including some potentially modern families, or at least modern clusters of families, something related to modern families. So it wouldn't be that surprising to have something like this which is potentially relatable to a modern family in the Middle Ordovician, even if that family has almost no fossil record, or none at all potentially. But you would not expect it to have exactly the same characters as the ones that we see today. So what we're looking for at this stage is a mosaic of characters. We're looking for the right type of body form, the right type of structure, the right sort of anterior details, the right sort of chaetal arrangement, and the ability to secrete a tube within that same group. And that, apparently, is true. We seem to have got that far, which is quite exciting, really. In fact, I would now go as far as to say that this is now a hypothesis. It is definitely not proven at all, just because we found something that matches up which seems to correspond to the images or the details that we're seeing in this fossil does not mean that A, those details are really there because we are at the absolute limit of what this microscope can do, B, that we have interpreted them correctly, and C, that it is therefore closely related to a modern group that looks at least superficially similar. So the next stage, as always, is to get a lot more information. And this means, really, electron microscope. Luckily, as some of you already know, we do have access to one of these. So at some point, we'll be able to head down to Cardiff and use the one that we have available to us in the National Museum and see whether we can confirm that these structures are as they appear to be. The other thing we would have to do, in order for this all to really make sense, is to dive into the literature. So we need to start looking up probably very old papers about the Magalonidae and see whether we can find descriptions of these tubes and illustrations of them. And thin parchment-like tubes doesn't tell us very much. Do they have this seam running down down one side, which is quite a distinctive looking feature? If not those, do other annelids have a tube like that? Can we start to limit the possibilities by which sorts of worms secrete particular types of tube? It's quite a slow process to get to the point of having any certainty. And that's partly what this channel is about. Although we do cover news stories as well, we're also showing you the process as it happens, as we're trying to work out what we've got. and before we have enough definite evidence to be able to publish it immediately. So you're going to have to wait for a future instalment. Hopefully sometime in January we'll head down to the electron microscope and try that and a few other things, and hopefully get some answers. But in the meantime, it just goes to show how we can still keep finding more things that we've overlooked, even in the boxes that we've already unpacked. And I really can't wait for the sun to come out and we can actually go and find some more new and potentially really exciting fossils. It is ridiculous living basically next door to a Burgess Shale-type fauna that is all yours. And I'm so glad that you lot are here to enjoy the journey and share it with us and see how excited we get about it when nobody's actually looking. Right, I will leave that there for now, and we'll be back with, I think we're planning another video for members shortly, and I'll do something else here, probably a little foray into the library, because I've been talking about these wonderful old bits of literature that we have to use in order to really make sense of fossils. And I'd like to show you some of that. It's about time. I did promise I would. So hopefully in the next couple of days, or 2 or 3, I'll get on to putting something like that together. But yeah, have a lovely new year for those who are watching this as it comes out, and I'll see you again soon. Thanks for tuning in.